Alright, you guys, this is the notes for January 10th, 6.6, part 3. Let me zoom in. Alright, so we've been talking about how to factor quadratics. Now we're going to look at solving quadratics by factoring. Okay? So, to solve a quadratic by factoring, you will factor the trinomial, which we've been doing, and then set each binomial equal to 0 and solve for x. All quadratics will have two solutions unless it's a perfect square trinomial. And we talked about what that was last week. Okay, so first we're going to start off by factoring this quadratic. We notice that there's an a in front, or excuse me, our a is 1. There's a 1 in front of x squared, so this one will be fairly easy to factor. So we start by finding factors of our last term, of c, negative 6. And my factors of negative 6 would be negative 1 and 6, negative 6 and 1, negative 2 and 3, negative 3 and 2. And which pair am I going to use? I'm going to look for a pair that adds up to be a positive 5, our middle term. So that's going to be this pair right here. And let's check and make sure. So 6 plus negative 1 is a positive 5. 6 times negative 1 is negative 6, so it works out. So remember, if we have 1 in front, or our a is 1, we can take these two and just create our two binomials by doing x minus 1, x plus 6. So we've been doing this. We've been getting to this point. From here, to solve for quadratics, you're going to take each binomial and just set it equal to 0 and solve for x. So in this one, to solve for x, we'd have to add 1 to both sides. So x would be 1. And this one, we'd have to subtract 6 from both sides and get x equals negative 6. Alright, for the next one, same thing. Our a is 1. So this will be fairly easy. So my factors of negative 18 are going to be 2 and negative 9, 9 and negative 2, 6 negative 3, 3 negative 6, 1 negative 18, negative 18, or excuse me, just 18 and negative 1. Alright, so again we're looking for a pair that adds up to be our middle term, negative 7. That's going to be 2 and negative 9. So from here we're going to write x in a positive 2, x minus 9, and that's how you factor it. Now to solve, just set each one equal to 0. So for this one, to get x by itself, we got to get rid of the 2. So we got to do the opposite of adding, so subtract 2 from both sides. We'll get x equals negative 2. From this side, we have to add 9, so we get x equals a positive 9. To check these, so to make sure they are correct, you can plug these back in to the original equation and you will get 0 if they are correct. So for example, if we plugged 1 back in here, 1 squared plus 5 times 1 minus 6 would be 1 plus 5 minus 6. 1 plus 5 is 6 minus 6 is 0, so I know that one's correct. So if you want to check these, you just plug these in for x, these two values, and they should give you 0. Alright, moving on. So this one's different because it does not have the 1 out in front, so it's a little bit more difficult, not too much. So the first step is, instead of finding factors of just the last term, you have to find factors of a times c. So our a in this one is 5. Our c is negative 3, so we're finding factors of negative 15. Alright, instead of listing out all the factors for this one, I'm just going to look, okay, if I find factors of negative 15, I want to add them to be 14. I can use 15 and 1. The question is, which one has to be negative? Well, if we add them together and the 15 was negative, negative 15 plus 1, we'd get negative 14. So we know we're going to use the numbers 15 and negative 1. because 15 times negative 1 is negative 15. 15 plus negative 1 is 14. Alright, because this one does not have a 1 out in front, we can't just factor it out like this. We have to take these two terms and replace the middle term, 14x, with 15x minus 1x. So let's write 5x squared. Again, replace the 14x with a plus 15x minus x minus 3 equals 0. Alright, from here we group them in groups of 2. I'm going to go ahead and group them into binomials. Remember to pull out the greatest common factor. So what's a number that can go into 5 and 15 evenly? The biggest number, that'll be 5. They also have an x in common. Alright, now I'll look what's missing from 5x squared to 5x. The 2, right? So we'll need another x. So if we multiply this out, 5x times x would give us 5x squared. 15x divided by 5x, that's going to be a plus 3. So over here we know we have to have x plus 3, because again, what's inside the parentheses should be the same. So what am I missing from negative x to x? The negative, correct? So I'm going to bring a negative 1 out front. Now I create my two binomials from this point. So the first one's going to be what they have in common, x plus 3. The second one's going to be what's on the outside of each parentheses. So this one's going to be 5x. We have a negative 1 outside on this one. So here is this trinomial or quadratic factor. And now to solve for x, I just set each of these equal to 0. So I'll have x plus 3 equals 0. 5x minus 1 equals 0. To solve for x here, I would just subtract 3 from both sides. I'll get x equals negative 3. From here, first I'm going to have to get rid of that 1. So I'm going to have to add 1 to both sides. Now I have 5x equals 1. Here's my x, trying to get it by itself, so I need to get rid of that 5. And how do I do that? Well, it's being multiplied by x, so I do the opposite, which is divide by 5. So I get x equals 1 over 5. That's 1, not 11, sorry. Alright, moving on. So this one we're going to work out the same way as we did the previous, because this again has a number out front. So I'm going to have to find the factors of 3 times negative 5. So again, factors of negative 15. Instead of them adding together to get 14, I need to add them together to get negative 2. Well, I know I'm going to use 5 and 3. Because the middle term is negative, I'm going to make the bigger term, which is 5, the negative. Again, I'm going to replace this middle term with these two terms. So 3x squared minus 5x plus 3x minus 5. So I'm writing the same equation, except instead of putting this negative 2x right here, I'm going to replace it with these two terms. Now I group them. Greatest common factor of 3 and 5 is just going to be 1. But I also see that I have an x in common, so let me bring that out. You can write 1x if you want to. I'm just not writing it because I know it's there even if I don't write it. Alright, what am I missing from 3x squared to x? In other words, what is 3x squared divided by x? Well, we're missing a 3 and another x, right? On this one, the only thing I'm missing is that negative 5. So over here should be 3x minus 5. And what am I missing from 3x minus 5 to 3x minus 5? Well, they're the same thing. So I can put a plus 1 out front. So from here, first binomial will be what they have in common, 3x minus 5. Second binomial will be what's on the outside, x plus 1. Now I just set them both equal to 0. This one I have to add 5 to both sides. So I'll get 3x equals 5. Then I have to divide by 3. So I get x equals 5 over 3. In this one, I just subtract 1 from both sides, so I get x equals -1. Alright, 2 more. So these I'm going to go through pretty quickly, so if you need to slow down, you can always pause it, and you can always rewind the video, so just go at your own pace. Alright, this next one, I'll have to do 10 times -3, that's -30 and finding factors of. So to add together to get -13, I can use -15 and 2, because -15 times 2 is 30, -30, excuse me. -15 plus 2 is -13. So I'm going to replace the middle term, group them. Greatest common factor here is going to be a 5 and an x. So inside I'll need 2x minus 3. So over here, I noticed they're the same, so I'll just put a +1 out front. Alright, now I need my 2 binomials. That'll be 2x minus 3 and 5x plus 1. Set them both equal to 0. So over here, I need to add 3, divide by 2. I'll get x equals 3 over 2. Over here, I need to subtract 1 first. Divide by 5, I get -1 over 5. Alright, next one, look. A is 1, yay! So easy to factor. Gotta find factors of 9. That'll add together to get 6. That's going to be +3 and 3. So I can do x plus 3 and x plus 3. Because again, our a is 1. That's the reason I could do that. Set them both equal to 0. And notice these are the same binomial. So in both of them, I'll get x equals -3, so you don't have to write it twice. And the reason all the rest of them have 2 solutions, and this one only has 1, is because this is a perfect square trinomial.